All right, so let us move on to the next part of the question, part B. So when you read the question, it says I've got a piece of sodium. So this is your reactant. It is placed in the beaker of water, your reactant again, and I have effervescence of hydrogen gas, your product, and solution of sodium hydroxide, aqueous sodium hydroxide, and that's also your product. So let's write it out in the word equation. Okay, so I have sodium plus water. It produces hydrogen. There is no need to write the word gas inside. Writing the word hydrogen inside is understood that it is hydrogen gas because that's the stable form of the element hydrogen. And this also includes sodium hydroxide. So let us write down the chemical formula now. For sodium metal is the element metal. So like we said just now, it is just the chemical symbol, right? So this is Na. Water, we all know this is H2O. And I have hydrogen. Hydrogen is a diatomic molecule as seen from the periodic table over here, diatomic molecule. So it should be H2, right? So it should be H2 plus sodium hydroxide is an alkali. It is an ionic compound. So it is made up of the sodium ion. Okay, it's made up of the sodium ion. It is also made up of hydroxide ion. Okay, and when I merge them into the formula, when I crisscross the charge, it will get NaOH. Okay, so let us balance the equation now. With one look across, you will notice that sodium is not the issue. There is one Na and one Na on both sides. The main problem will be hydrogen, right? So I've got two hydrogen here. There is two hydrogen on the product side. There's also one hydrogen here on the product side as well for NaOH. So what can I do? I can start by increasing the number of uh, molecules of water. So let us try. If one molecule of water is not able to balance my equation, perhaps let's try with two. So with two molecules of water, I will end up having four hydrogen atoms and two oxygen atoms. Right? The only place where I see oxygen atom is on the right-hand side of the equation, which is at NaOH. So to make sure that the O is balanced, I can introduce a coefficient 2 in front of NaOH. So once this is done, let us take a look at the number of hydrogen. For hydrogen, in H2, I have 2 over here, and I have 2 from the whole of NaOH, 2 hydrogen from 4 of NaOH. Right, so this will give me 4, right, which is what we want. For oxygen, it is only from NaOH over here, so there's 2 sets of NaOH, which means that I have 2 oxygen. Okay, and looking back at here, hydrogen and oxygen are balanced. However, if you go back to your sodium for Na, you notice that it's no longer balanced anymore because of the coefficient 2 in front of NaOH over here. So how many NAs do we have? We actually have 2 Na now. And on the left-hand side of the equation, I currently only have 1. So to balance it up, I need to put a coefficient 2 in front of Na, which then causes it to be updated to 2. So with that, our equation is balanced. So let us now put in our state symbol. Our state symbol will then be, we have a piece of sodium. If it's a piece, it is solid state. Then water is in liquid state. Effervescence of hydrogen gas. So the word gas is here, quite straightforward, it is G. And for a solution of aqueous sodium hydroxide, solution tells you is AQ, aqueous also tells you it is AQ, right? So actually this is our complete balance equation with state symbols. So we can write it back in our in our blank. So I have 2Na solid plus H2O liquid, right? So this is 2H2O liquid. I have H2 gas plus 2NaOH aqueous. And this is my balance equation.